pushing the weld without a preheat. This is an excellent example, and it shows you that I'm unable to get the good flow from side to side because the base material is sucking the heat out, and the droplets are not easily transferred from your rod into your puddle. And that's one of the drawbacks of not preheating. Alright, you just saw me crash into my tungsten into that weld. And now I'm going to go ahead and show you it is not drastically dirty, but I'm going to bring you in close and I'm going to go ahead and show you how I go about cleaning this, and then we're going to put that little spot. I came out this morning and I saw the root was a little square on that side, and I wanted it to be radiused slightly when I finish it off, so I was just adding in one little bead at the bottom there. And anyway, you saw is the mishap. I did all that welding yesterday, never dipped it, and the first attempt today, and of course maybe I didn't have enough coffee or something. All right, let's go ahead and move you in closer so you can actually see what I'm doing with the tungsten and in the weld. And we're just going to take a piece of steel plate. This is just hot roll plate, just a piece of it, and we're just going to set it here, and we'll get the camera in on it, and I'll show you how it ignites it and cleans it. We'll take care of the thing, and then I'm going to go ahead and create a fresh grind on the end of the tungsten, and then show you in actually balling up. But just in case you were doing some welding and you had a piece of steel around, this will give you a chance to go ahead and quickly come over the steel, clean your tip, go back to what you're doing. I used to weld on a lot of junk propellers, and constantly they would be spitting, saltwater pockets, all kinds of different things that are in there when you're welding. And every once in a while you get a little bit of a dirt on your tip, and it's not that bad, and you want to just clean it and get back to it. You're welding on junk, so just maintaining a semi-clean tip, most of the time you're able to put enough aluminum onto a propeller blade, a salt-ridden propeller blade. Alright, and those are cast, and usually they're filthy, and all kinds of things come into play, but you can put a good weld on them, and most of the time you're putting more than you need and then shape it off. That was the game plan back in those days. Okay, you can see that ball it's got a little bit of a shine to it, but it's not a real high gloss ball. Normally a good clean ball on the end of your tungsten is crystal clear just about. Okay, so what I'm going to do is I'm going to light off, and then I'm going to lift my torch up, and then you're going to see the arc happen between the steel and the tungsten. I'm going to lift it up and make it gap, and by making it gap and over the steel here, I'm going to be able to take the impurities right off of that tip. Okay, let it cool down. Okay, now we got a real nice gloss on the end of that ball right there. All right, now we can go ahead and we can finish up on our part there. We got one little area that we want to add some weld in. So let's go ahead and do that, and then I'm going to come back and I'm actually going to show you how to create a ball brand new. On this welding that we did on here, our oversight was that we didn't set the on button inside on the lens there, and we didn't have the shielding lens working, and that's why it was extra bright, and we're sorry we wasted that amount. We were working on the project, and it was we had a break interruption, came back to it, and the lens had gone into its timeout mode, and every once in a while you got to click it just like that and make sure that it's on, and I overlooked that. Alright, so we're going to come in here and we're just going to fill this radius right in here. That's where we hit just before we got to the end there, so I had to stop, make sure that we had a clean tip so I can finish. Yeah, I waited till I had it hot enough and then I drug back, and actually I have just a little tiny bit of a spot over here, and I'm just going to come in here and touch this off. Alright, now I'm happy with that. Okay, when your electrode touches and you get discoloration and you don't quite have the clear gloss mirror finish on your tungsten again, it's time to pull it out and kind of dress it off, and then I'm going to show you how to clean it and recreate the ball on the end of your tungsten. Not that that's how everybody welds aluminum, but that's how I approach aluminum, and to get that, this is how you go about it. Okay, so I drop this out here, and you can see that the discoloration's here, and you can see a little bit of the aluminum or discoloring on the side here. So we want to take and we want to flat that ball off, come back a little bit, and then kind of just flatten the nose of that on the grinder. All right. First I just lay it on its side right here. I kind of just take the side of that ball right off of there. Grabbing a little bit of that. Okay. Now everything else I want to keep dress the end, just so you know there's nothing on that end. Alright, let me pop on my welding lens here. There, okay. Get my gloves on. Now we've ground the top of this plate here just to make sure that there's no mill scale or anything else on here. I haven't, most of the time it has been on cold roll, that type of thing. Clean piece of steel is all you need. We used to always have a plate that we just ground off the top, kept it dressed. Now you can see that my tungsten's square, just kind of a blunt. Now what we're going to do is we're going to actually put a ball on that, and what we do is we go ahead and initiate an arc, tilt it up, give it a little bit of gap, accelerate on the amperage, and let off, and there's our nice clean ball. Now if you have a slightly dirty tungsten, sometimes you can just clip it off with your cutters and then get right to it, right to the steel plate. Sometimes you can actually have a small ball on there, you've dipped it in like I did, and then just touch it up by igniting over the steel and dressing up the ball once again. But once in a while, when you get too much stuff on there, you got to cut it, clean it, and that's where this would come into play, to put the new fresh ball. And the reason why you do it now, I mean, most of the time you can go right welding right to aluminum, and you can create the ball as you're welding. But this way here, it lets you put that ball on there, and then you can go right on over to your project, and then you're ready to go from get-go. All right, we're out here at the mill, and we're getting ready to set our part up so that we can face this off, drill a hole through here, and get an opening into this face here. But we're going to concentrate with the bore and the hole that's going to go down to this depth, and the threads and everything else to hold our poppet. We haven't brought that in here yet. We're going to go get that in a minute. But we need to move this vise off of here. We're going to use these two hold downs and the T-nuts and the bolts here to go ahead and bolt our two angle plates down. And then we're going to be bringing this in from the back side so that we can control the angle of the rotation here. And then we'll locate center, the distance back from the face, and all of that we want to go, and then go down and create that hole. So let me go ahead and get the wrench, and we'll get this vise off of here. All right, we took a straight edge and we clamped both of these parallels together with a gap in here that we wanted to have to access the visual of this center line plus our hub here. Now we need to clamp this on here, and there's some flats back here that we can grab, but you know, I don't want to be off on anything, so I want 100% positive grip straight in on a couple areas, and if I grab those two holes right there, I'll be doing good. So I'm gonna use 2 ball bearings just like that, and then clamp, and that'll be pushing right down in there, and there won't be no way of marring anything. With just straight pressure, it won't damage the holes, and it give the clamps a nice seat on here. So I'm going to try to get one of them at a time in here as soon as I get the little ball. Okay, no problem there. All right, and we're going to use our Bessie clamps here and put them on in this direction so I can grab this side here, and this will be holding the ball in on that side there. I'm going to hold the first one up here. Now I'm going to try to get this set just about like that, and I'm going to probably bring the camera around to this other side here so you can kind of see that at the same time that I'm setting this up. I think that's a good height right there. At least I have this full surface right here on this front face here is letting us hold straight against that, and it's going to be a good purchase. All right, so we're going to put this behind here about that height there. We're going to hold that ball in there. We're going to get the foot on here. Now I like that. Right away you can tell it's solid. This foot here is able to ride. You can move this a little bit, and you can tell that it's not rocking or rolling or wanting to flip or roll the ball out of there. Now with one of those on there, I could lightly tap. Let me get the right kind of hit here. I'm going to be beating on the aluminum. But see, we're able to tap that down or tap that up, get that angle. Now I'm going to get a straight edge on here, and then we'll be able to determine that plumb line we want to get. Okay, I found a parallel that was pretty close to the distance from the line over the center of edge of one of these. And when I made these angles, I also trimmed the side square, so that's good. I'm that way on the bottom, so I'm going to go ahead and tap. I'm going to go ahead and tap this up until I stare down, and just a little bit down. Okay, that line is looking pretty parallel. Now I'm going to go ahead and throw this ball in here. Now You know what, I can, well, that's good. That'll be great. You know, two's gonna be good enough here. All right, put our parallel away and our hammer away, and we're ready to go ahead. I think I'm going to use my parallel here because we're gonna touch off with the edge finder here, and actually we can touch off of this edge here, and then we can measure in from the rest of this right here. All right, let's go ahead and bring the table up here a little bit. All right, and we'll go ahead and zoom you in a bit. All right, now I'm going to go ahead and bring this on down here, and then I'm just going to lightly tension that, and I'm going to lock my spindle so that and I'm out on my auto feed, and of course we're locked up there. Okay, this aluminum, we can spin them just a little bit faster than that. We'll go up to 1115 here. Alright, now I'm just going to put a couple drops of this Alumatap. And I'm going to come over, I'm coming over to this high spot over here, because that's where I'm going to touch first. Okay, lightly touching. We're going to shut it off here. We're just going to kind of look physically what we have over here. About 1/8 of an inch. It's got to go in there. All right. So we'll set 0 here. And we'll go ahead and we'll come on down 50 thousandths. We'll drop the juice there. I'm going to put the lid up there so I don't lose it. Alright. I got my hand, I got the knee lock, table in and out, and cross semi-tension on the brake, just because this is an old mill and it's got a lot of play. But I'm just going to come in here, kind of take off the top there. Looking really good. Let's go ahead and take another 50 thousandths here. Alright. Got almost a flat up there. Let's get down here and kind of look at the height here we got. And the washer surface and the bottom of the the pullet there is just about 100 thousandths or so. Now if we push that in, which we're going to have to make sure we got that, that's almost flush with that edge right there. Okay, what's this diameter look like up here? Definitely plenty to seat there. Would be nice if there was just a little tiny bit more right on there. Okay, I'm going to go get some acetone. I'm going to kind of clean this up right here. I'm really content with this height, maybe a light skim just to blend it in, but I'm going to go get my Heliarc torch, and I'm going to put a little bead across here. I want to go ahead and I want to bring that material up. All right, that only took us 2 seconds to go get our leads. And you know, it's a toss-up whether you want to pull this out of here and go put it back in on the welding table or whatever. And you know, I don't have to take it out, don't have to run it in there, don't have to come back, don't have to set it up, even though it's not a great setup to where we're at right now. But right now we don't have to touch it at all. Alright, and we move acetone completely out of the room that we're welding on at Always blow it with some air. I also, we can reset our height. I'm not worried about that, but I am worried about maybe moving and catching my glove or my hand. And all right, number one important rule about welding on any machine is put the ground right on your work. This is grounded solid to this. We're not going through the machine, we're not going through any bearings and situations like that. Now I'm going to be able to look from this side, so I don't think I'm going to move at all. I'm going to leave it exactly right there, and I'm going to put the material on there that we need. Now I'm not going to bother putting the auto darkening lens on the camera. I think you've seen enough weld. All right, I think I'm going to be real happy with that. Okay, we're going to go shut off our weld machine and coil up our leads while this is cooling down, and then we'll come back to finish up our cuts. All right, we put our end mill in there. This is cold enough to touch it. I can still feel it's warm. That gives you a pretty good view of the weld there. Just real quickie here, I'm going to go ahead and take a photograph of it from this side here so that we have that on file. Boop. Okay. All right, come down. We're going to touch off here. Okay, locking in our piece again. A little squirt of Alumatap. Almost a perfect blend there. We're going to go ahead and take a couple more thousandths on the depth here. That's 5. And I can see just a little valley right there. There's 10. Little drip here. Beautiful. All right, now this is why I have the extra long leads on my TIG torch and everything else, is so I can come all the way from the other room and come in here to any one of my machines. The TIG welder used to be in the middle of the shop, and I used to be able to go out the front door and go out the back door. And now I can get to this mill, get to the K&T, and I can get to the lathe and the drill press if need be. At first I was going to conserve myself with come over here, touch off, and try to create that hole going down in there with what should I say, with minimum amount of wall or angle, try to get that piece over there. And then I'm thinking, you know, this is completely support and compression, so I want to use 100% of my hub to support that. It doesn't really matter the path of the opening from inside the chamber to the outside of the chamber, as long as it has the passage of diameter. or the equal of twice that diameter of that cross hole, the piss holes. There's 2 of them there, and I'm sure that those are what combined diameter equal the passage that's supposed to go through to operate that valve. So what I'm going to do, or make the efficiency of that valve, I should say. Alright, I put the transfer punch, which is 1/2 inch, because I just pulled a 1/2 inch tool bit out of here, and I have a guide that's usually for setting up 3/4 inch holes, so I can transfer punch that. And I'm just using this as a location, an eyeball location. Alright, and now I can go ahead and go forward and aft here, and I can go port and starboard. I like that right there. That looks good to me. Now what I'm going to do is I'm going to go ahead and bring this up and go ahead and pull this out, and I can put in my tap follower. Alright, so we can slip this up here, and now we can visually, we'll measure the width of this, the depth from this side to the inside there, and then we'll be able to come over from this with a straight edge this way here, and we're going to measure basically where that line is in reference to the space out here, how far we are before we actually drill this. So I'm going to take 5 here, and I'm going to go ahead and figure that out. Okay, we take this right here was 715 thousandths thick. Then we took and we measured into that farthest in register that we're actually going to be drilling in the face there, and we came up with 885. We take that to get difference, and it's 170. We verify by measuring from the backside into there by the scale, and so that comes up with 170. Now we need to know where our center is from this surface right here. So we take our scale and our parallel, we butt them together, and we hold them right up here, and we found out that that is 420 thousandths. So we took 420 thousandths minus 170 is 1/4 inch. So we're going to be, center of our hole is going to be 1/4 inch in from the face that we want to come out to. So when we take this, after we do our depth and everything else, and we'll know our depth from here down wherever, we can measure all of that. But we'll know when we come in to drill this way here, we'll know the depth to that hole. Alright, so now what we want to do is we want to go ahead and get set up with drilling our breathing hole all the way down to the depth. And then we're going to come in here and we're going to drill the tap size hole, and after we drill the tap size hole, we'll run the tap in there, and then we're probably going to do a chamfer. I took the scale and I measured down in that general area where we're going to intersect with the hole, and I like 1 5/8 on the depth. I chose a 152 thousandths drill bit because it's a good sharp one in my collection. That is my approximate double of flow to the 95 thousandths hole that I find in the side of the valve itself. So I'm just figuring twice that size, and I think 150 is going to be well enough to do that. I'm just a good educated guess. I'm not going to say it's exactly. Alright, little aluminum tap here. I set my travel dial on my depth here. I'm keeping this clear. This weld build-up drill is real nice. I'm down about 800 now. 900. I just don't want it to gall up, clog up. But that's why I also use this 4643 as far as the rod, because it is a pretty nice machining